Using a regular deck of 52 playing cards, what's the probability of each of the following? First, drawing an ace. So the probability of drawing an ace is equal to the number of ways that we can draw an ace divided by the total number of ways we could draw a card from the deck of 52. And so this is going to just be 4 over 52, which is 1 over 13. Now, next one, drawing a card that has a number less than 8. And so that would be drawing a 2, 3, 4, 5, 6, or 7. So 2, 3, 4, 5, 6, and 7. So there is 6 different number cards and 4 suits. So this is going to be then the probability that it's less than 8 is going to be 24 over 52, which is equal to 6 over 13. Rolling a pair of dice, find each of the probability of each of the following. The probability of rolling a 7 or 11. So this is going to be the probability of 7 or 11 is equal to the probability of rolling a 7. There are 6 outcomes when you roll 2 dice out of the 36. Plus, there is only 2 ways we can roll an 11, either a 6 or a 5, or a 5 and a 6 out of the 36 possible outcomes. So this is just 8 over 36, which reduces to 2 over 9. Next, the probability of rolling a 7 or a number less than 5. So then that would be a 2, a 3, or a 4. So the probability of rolling 7 or less than 5 would be equal to the probability of rolling a 7 plus the probability of rolling a 2 plus the probability of rolling a 3 plus the probability of rolling a 4. So all of those would be favorable outcomes. Probability of rolling a 7 is 6 over 36 plus there is only one way you can roll a 2, and that's with snake eyes. So that's going to be 1 over 36 plus 2 ways we can roll a 3, either a 2 and a 1 or a 1 and a 2 out of the 36 possible outcomes, plus 3 over 36, which is the number of ways we could roll a 4. Now, so this is going to be then 12 out of 36, which is 1/3. A box contains 8 red balls and 5 blue balls. You randomly select 3 balls at the same time. What is the probability that exactly 2 of the balls will be red? Now this is different than questions we did when we started the unit, in that the probability that we get exactly 2 red, okay, is we're not drawing out one at a time. We're grabbing 3 balls out of this, and so the number of ways that we could choose 2 red balls would be the combination of 8 choose 2. And so here, because order is not important, we're not saying that we got a red first, a blue second, and a red third. Order is not important, so this is a combination. So this would be the combination of 8 choose 2 times the number of ways we could choose 1 blue ball out of the 5 is going to be the combination of 5 choose 1. Now the total number of ways that we could choose 3 balls out of the 13 will be the combination of 13 choose 3. And this is going to be equal to 28 times 5 over 286. And so the probability then is going to be 70. This will reduce to 70 over 143. Four cards are selected at once from a deck of 52 cards. And again, since it's at once, order is not important here. So we're dealing with a combination. Now, what is the probability that you get one from each suit? Well, there's, since we're picking 4 cards, then the probability that we get one from each is going to be the combination of 13 choose 1. So we're going to pick 1 card of the first suit, then 1 card of the 13 of the other suit times 13 choose 1 times 13 choose 1. So basically there are 13 ways you could choose a club, a diamond, a heart, or a spade, and we don't care about what order we choose them in. And the total number of ways we could choose 4 cards out of 52 is the combination of 52 choose 4. So this is going to be 13 to the power of 4 times, divided by, now there are 270,725 ways we could, 725 ways we could choose 4 cards out of the deck of 52. And that reduces to 28,561 over 270,725. Sorry, and that does not reduce.